In this problem, we are asked to find out the limit of this expression, where this bracket thingy represents the greatest integer function. To solve this problem, we just need to do two things. A. Be aware of limits. B. Know what the greatest integer function does. First, in mathematics, a limit describes the value a function or sequence approaches as its input approaches a certain value. When a finite-valued expression, like sin x over x, reaches an indeterminate form like 0 over 0, it's still possible to find its actual value using limits. In this case, it approaches 1. Second, the greatest integer function does exactly what its name suggests. It finds the greatest integer less than or equal to x. For example, the greatest integer less than or equal to 1.35 is 1. For minus 1.35, it's minus 2. Confused? Let's clear it up. Take any number between two integers. Using this function, we always bring it back to the closest integer before it. Now, let's take a look at the graph of this function. Consider the line y equals x, which maps all x values to the same points on the y-axis. Now draw lines parallel to the x-axis through the integer points on the y-axis. Take any point on the line y equals x, it always drops to the floor, landing on the horizontal line just below it. So the line y equals x gets piecewise projected onto these lower horizontal steps. When we repeat this for all points, the graph starts to look like a staircase. That's why this function is also known as a stepwise function. This green line, y equals x minus 1, helps illustrate that the function is always bounded between y equals x and y equals x minus 1. Now, let's apply this idea to our problem. The greatest integer of k times x is less than or equal to kx, and greater than kx minus 1. Don't get scared by the expression. It's just this inequality summed from k equals 1 to n, just as in the problem statement. Taking x common on both ends of the inequality, we can write the sum of natural numbers from 1 to n as n times n plus 1 over 2. And the minus 1, when summed from k equals 1 to n, becomes n. Now, divide the entire expression by n squared and apply the limits. As n becomes very large, 1 over n tends to 0. Now we can see, the entire limit is sandwiched between two values that both approach x over 2. This implies that the final answer is simply x over 2. Thank you for watching. If you found this video helpful, don't forget to give it a thumbs up and subscribe to the channel for more insightful lessons just like this one.